Hi everyone, my name is Abel Grey Cantoma. I'm from Greatest Design Consult. You can reach me on this number or you can call me on any of these numbers, okay? Today I'm going to be showing you a very great software which uh, I have known for quite some time now. This software is actually very great. It is called Quickcivilseries. This is the version 9. I am happy to let you know that Quickcivilseries version 9 is actually very much is out now. Okay, it's out now, and the software is very great. Okay, it will interest you to know that this software is actually an indigenous software. It's owned by a Nigerian, which is a very great news, and a lot of Nigerian factor is actually put into consideration in this particular software. So it's very good. If you're a Nigerian, I will encourage you to get this software, or you're an African, it is very important for you to get this software. It's actually one of the most easiest software I have come across. In all sincerity, it is one of the most easiest. It is actually very straight to the point. 90% of the job boils down in the modeling. Once you are done with the modeling, you are done literally with the entire workload of this of your design. With this software, you can actually generate your entire design in 30 minutes. I'm telling you the truth. It generates both the analysis, your design reports, your concrete reports, your bar bending schedule, and then the detailing is superb. If you see how this detailing, how the software actually generates your detailing for you. Okay, I just did a modeling. In this modeling, let me come to using this software. You can see here, I have a cantilever here, and then I have a cantilever beam here. So there is no support here, and you are going to see how this software is actually going to actually analyze this design just with a click. It will analyze it, design it, and it will generate the detailing, which is the selling point of this software. I must tell you the truth. But quickly, without talking much, I'm going to create a new project and start this design, do this modeling afresh, in order for you to see the power of this software, what this software can do. If I come to, let's say I just want to analyze and design this whole thing again afresh. Let me just analyze and design it, then we are going to pick it up from the beginning. Okay, so you can see if I click on yes, you can see no common errors found in the modeling. So if I click on OK and I click on yes and I click yes, so basically it's very interactive. You can see it's always asking you at every point what you want to do. Okay, so I'll click on yes, I'll click yes, click yes, okay, and I click yes. Now whatever analysis it wants to actually carry out, it will always ask you, and then you have to give it the go ahead for it to continue. So it's designing the analysis, it will ask you the design, it will also ask you if you want to carry it out. You can see by simply just clicking automatic design, you can see all of these are just coming out for us to select. And then here you can play around, pick the reinforcement you actually want the software to make use of for you. Okay, you can see the bottom outer layer, the bottom second layer, the top outer layer, and then your distribution bar here. Okay, I always like my distribution bar to be white. And okay, you can also play around with the spacing for your distribution bar. Okay, I always like to use this, but then please don't cram this. It's not a standard for you to adopt. Okay, just know that design, when you are doing your design, it's about safety, and then it's about economical, how economical your design is and how safe your design is. So if your design is safe, then we'll talk about economical. So your design should not just be safe, it should be economical as well. Okay, so you don't adopt this. So if I click on apply changes and I'll click yes, okay, so you can see it's bringing out the one for my beam. I can also specify the minimum bar diameter for my beam, and then the maximum bar diameter for my beam. I don't want it to go more than 16 mm because this project is a very small design. It is a very small building project that should not require high number of size of reinforcement. Then the minimum link diameter, let's say I'm using Y10, and then maximum link spacing, I can leave it at 250 or I can leave it at 300. Okay, then minimum span top bar diameter. Okay, let's say I want to use this. So you can just take out your time and pick out, specify all of these informations rightly, and that is all. Now you can see here it says modify depth of beam options. So if you modify depth of the beam option, now it's telling you don't modify depth of beam option. Okay, so whatever you have specified in your from the settings, which I'm going to be taking you through from the beginning as well. I'm going to remodel this from the beginning in order for you to see how I got here. Okay, so I just want to run the design so you see the detailing, how it comes out. Okay, so whatever you have specified from the beginning, it won't go lesser than that. Okay, so by clicking this, that means it won't go either higher than that. It won't go higher than that depth, no matter what. It won't go higher than that depth, so which is not very good. If you click on modify depth of beam, and except if you are very sure that your design should not exceed a particular depth that you have specified, then modify depth of beam, okay, if necessary, and make floor beam depth uniform. So what this means is that by the time you do your design, and then your design probably you actually ask the software to use 450 depth of beam, and then the 450 is not sufficient at a particular point, and then the software will now increase that particular beam to a particular depth, let's say a depth of 600. By the time the software now adopts 600 as the depth that is sufficient, okay, now what the software will now do for you, it will now generalize that every other beam should be 600 depth. Okay, which is not very good. It's not going to be economical. So the best option to actually adopt is either you adopt this particular option, where by the time you provide a depth of a beam of 450, the software when it does the analysis and all, and it sees that a 450 depth is not sufficient, the software will now adopt a depth probably 500 or 600 or whatever that is sufficient for that particular design, and it will only increase that particular beam. It will not affect any other beam that is on that design. So this is actually the best option to actually adopt. So if I click on apply changes and I'll click on yes, now you can see size column, don't size column. Okay, see, these are column size. Leave column dimension the way they are, so you can actually allow, it's more like what we did for the case of your beam. Okay, in this case too, it can resize the column when that particular column cannot resist that particular load that is acting on it, so it can resize it to another probably a higher cross section. So if I click on yes, now I can specify the minimum column width, the whether in width and in height. Okay, so that's the cross section. For a circular column is 300 and all that. You can just do with all of these settings, and if you are comfortable with it, you click on OK, and then you can see it's now based on what we have. It has actually generated 3 different type of column for us. You can see the first column type is 225 by 225. The second column type here is 225 by 300, which is this, and then the third column type here is 225 by 225, probably based on maybe reinforcements that are inside and all of that. So you can probably just adopt one particular one, or we adopt this one, which is telling us column level 1, column level 2. You can see at a level 2 is telling us that it is 300 by 225. The other level here is telling us is 225 by 225. So we can just adopt one particular type of column, and then we'll click on yes, and click on yes, and we'll click on yes, we'll click yes. Okay, then the minimum base thickness, we can just specify this to be 350, and then the minimum base length, I always like to adopt 1200, and then the length interval for both height and width. Now what this means is that whenever this 1200 when this 1200 is no longer sufficient, okay, when the design now requires probably a higher cross section of a footing, okay, now the software will do this design in an increase of 100 increase. For example, if it wants to increase, it will test for 1300. If 1300 is not sufficient, it goes to 1400. So it is actually a multiple of 100. Okay, so if I make it in 200, it will be, the next one will be 1400, then another one after that will be 1600, and then another one after that will be 1800. That's multiple of 200 if I change it to 200. So but I would like to leave it at 100, so it's going to be an increment of 100 like that. So if I click on yes, and then you can see this staircase design, it has not really been inserted, so I'm just going to click yes, but I will just close it because I do not specify a staircase here. Detailing foundation layout. Now this is actually going to generate our detailing for our foundation layout. Okay, we'll click yes. Detailing pad foundation details, yes. Column, you can see as I'm clicking yes, it's generating the detailed drawings for us by the side. Okay, yes, you can see this is our column detail. You can see I have 46 y10, which is not actually very okay for me, probably because of the settings I did. I'm going to recorrect that as in the next model I'm going to do. I will take my time to correct all of that, and then you are going to see how this thing comes out. You can remember in the previous versions you do not really have other support at the you don't really have internal supports really showing in your beams, but you can see in this case it's bringing out those internal supports. You are going to see by the time we view the detailed drawing, you are going to see how this detailed drawing are actually going to display, and you are going to love it. So if I really want to generate my calculation sheet, I can just click on prepare calculation sheets, but I don't want to do that for now, and I'm going to cancel some of these things here right now. Now you can see this is the detailing for our beam, which was generated by the software. Now you can see here so here now I will just come to this my detailing tab, and I can click on any of them to generate the detailing. So if I click on floor and I click on the window anywhere, you can see the beam detailing has been generated. All I need to do is just to scroll down to view it. Now you can see this is my general arrangement for my beams. Okay, it's telling us this panel is a two-way, this panel is also a two-way, then this one is telling us is a cantilever, and then this one we can see here is a one-way slab. Okay, so if I click on my roof beam and I click on the end of the window, it's going to generate. Okay, I did not specify my roof when I was doing the modeling. Anyway, I'm going to show you that when I adopt a very small design just to demonstrate. Okay, so I will show you that as we proceed. You can see the foundation layout. I deliberately made this particular beam a primary beam, and then I made a beam. When we go to the slab, come here, you can see this beam is a primary beam, then this beam is a secondary beam. So this beam is acting on this beam as a cantilever, as a point load. Okay, So that is basically what I did, and it's deliberate. So you will appreciate it more when we come to generating the beam detailing. You are going to see how this beam comes out as a cantilever. This also comes out as a cantilever. Okay, so let's go now to that of the slab. Perfect. You can see the slab detailing. You can see the slab detailing. You can see how great this detailing is. You can see how this slab detailing is. It's very, very superb, I'm telling you. Let's come to this cantilever side. Oh great, you can see how this reinforcement was returned back inside. Okay, it's returned up to the 1/4, which is very great if you ask me. It's very, very great. So the software is very good. Let's come to the floor beam detail, and I'll click. Good. You can see the details of our beam. So you can see in this particular version all those supports. You can see all those internal supports are showing, but in other versions they are not really displaying, but in this one it's showing, and which makes it very great if you ask me. Sorry, I'm trying to look for a particular beam. There is a beam I'm looking for. Okay, this is the beam. You know, I had a cantilever beam, a cantilever span there. So this is exactly what I was looking for. You can see it coming out very well. Okay, it makes it great. Okay, so let's come to the column detail. Let me see this one. Something was actually wrong somewhere. I was seeing some informations that I'm not very cool with, because I have, you can see this is 4y16, 46y. Oh, this is the links. I was so scared. I thought it's the longitudinal bar. Okay, so this is the links, 46y10 at 200 spacing. Okay, so if you check the entire length of the column, if you divide by 200, it's supposed to give us that value. Okay, so if it is 3 meters, divide 3 meters by 200. Okay, if it is 4 meters, divide 4 meters by 200. It will give you that particular spacing of your links, number of your links rather. Okay, so it's very great. You can see everything has been done. The detailing has been generated 100%. So now quickly I'm going to demonstrate how to start a modeling afresh. So what I did now is just to show you the detailing, because I've done the modeling already. If I come to my file here, I can click on new, and I will click on yes. It's very interactive. You can see it's always guide you on whatever step you actually want to take. Okay, so if I click on yes, then here now you can see this particular menu that pops up for me. I can impute all of the necessary values I actually want to make use of. Okay, so I have the characteristic strength of concrete, the characteristic strength of steel. I can impute whatever based on what I want to actually adopt in my design. Okay, then the depth of the beam as well, I can specify the depth of the beam. You know, normally it's customary we use 450 as depth of beam for most designs. That's the first cross section we make use of. So if I click on apply changes, then here now I will click on my rectangular and then I will drop it here. If I drop this panel here, let's come down here to this point. Let me quickly demonstrate something here. Okay, nice. Now you can see we have our y direction, we have our x direction. So our x direction, which is the horizontal, our y direction, which is the vertical. So if you look at this panel is standing on 1500 along the vertical direction. So because this, it's like a graph. This is 0, it's coming from 0 to 1000, 2000, 3000, 4000, 5000, 6000, like that similarly. So here is also starting from 0 to 3000, 4000, 5000, 6000, like that. So this is 5500. Okay, so this is standing at this panel. I created this panel at 1500 by 5500. So if that is correct, you can see along the y-axis is 1500, along the x-axis is 5500, and then the size of this panel is actually at 3500, and then the width is 3000. Okay, so the height is 3500, the width is 3000. Okay, and then it goes as far as even telling you whether this panel is a one-way slab or a two-way slab. You can see this panel is a two-way slab. You can, if it's a cantilever, you can switch it to a cantilever. If it's a roof panel, you can switch it to a roof panel. If that area is supposed to be a staircase, you can change it to a staircase. If it's a waffle slab or a wrist slab, whichever, you just, all you need to do is just to click and it changes. So but as you know, if you do your ly over lx, that's the long span divided by short span, is going to give you this panel as a two-way slab. So you can do that. It's very simple to know whether it's a two-way slab or a one-way slab. Then this panel, all I need to do now is probably, I just want to make it very, very simple. I will copy to the left. So if I copy to the right, I can as well copy this to the bottom. Okay, so here, let's say I'm going to be having a cantilever here, so I'll copy here to the right. But then I'm going to do something to this panel. I'm going to reduce the size of this panel, and I will make it for 900, just to make it like a 900 cantilever. So to do that, I will just go to where I have the width of this panel, and I will change the width of the panel to 900. So by the time I change the width to 900, it changes to 900. Okay, so I'm going to be having a 900 cantilever, and then here I'm going to copy bottom, and then, sorry, I made a mistake there. Select, reference, copy selected to the bottom. Okay, so this panel, I will change this one to 1500. Let me change this to 1500. So at that point, I'm going to be having a cantilever. So is the height I'm going to change to 1000, let's say 1200. Okay, so this is going to be having a cantilever beam here. Here we are having just a cantilever slab. So because I just want to do some little illustration of what is going on here. I want to have a point load at a particular point. I'm thinking of where to introduce that point load just for illustration, so that you will understand the possibilities of what you can achieve with the software. Okay, so I don't know where to. I'm just thinking of something very simple that I can do. Okay, here. No. All right, let me just introduce it anywhere. Just to, let's say this beam, I will make this beam a primary beam. I will make this beam a secondary beam. So this beam is going to be acting on this beam as a point load. Okay, just for illustration purpose. Okay, all right. Okay, so now if that is correct, so all I need to do now is to click on create new beams / spans. So if I click on it, you can see automatically the software will actually introduce the names of these beams with their cross sections. Okay, now with their names, okay, the names of this beam telling you the thickness or the cross section of that particular beam. You can see it's telling us that each of these beams is 450 by 225. So but remember I said I want this to be a cantilever, but the software, what it does for you is wherever you have intersection of beam, the software will automatically on its own introduce a column. Okay, that is why it's very important. You must be a civil engineer or a structural engineer for you to really go into structural design. Okay, so if you don't have a background knowledge of these things, you will be performing a lot of blunders. Okay, so you have to be very careful. Okay, because structural designs are very sensitive. It's either you will under design or you over design, and the both of them are dangerous. Okay, so I will delete this beam. So I want to assume everyone watching this video is actually an engineer, or is actually a civil engineer. Okay, so I will delete. So I have deleted these beams. So this panel is going to be a cantilever, and then this one here, I'm going to actually make this particular beam a secondary beam. So what that means is that it's going to be acting on this beam, also acting on this beam as a point load. So in order for me to achieve that, I will just come to, because this beam, this is the starting point, this is the end point. Okay, so at the end point there is a primary beam that is acting on, and then at the start point there is also a primary beam that is acting on. So this beam now is actually a secondary beam. So then the next thing here I'm going to do is here, or let me make it here. I'm going to remove this particular column, because you can see this one that are looking like in form of a cycle are actually telling you these are the positions where your columns are going to be inserted. So because I don't want to have these supports here, I can actually decide to click on delete. So if I click on delete and I click on yes, now I'm going to stretch this particular beam to make it one full span. So you can see I selected stretch span, and then it's telling us our beam 1 span 1, which is this is beam 1 BM1, and this is the first span, is what we are going to be stretching. So it will stretch to the other support. So what that means is that it's going to be taking, it will knock off this particular support that is here. So and then I will click on yes. So you can see this other cycle is not as thick as these other ones. What that means is that this support has been taken off. So right now I think we are fully done. So what I'm going to do next is I will come under my tools and I will click on dictate cantilever slab. So if I click on dictate cantilever slab, if I select this slab now and I go down to check what type of slab is this, you will discover that the software will tell us that this slab is now a cantilever slab, and is going to analyze it and design it as a cantilever slab. Because I get a lot of questions, you can see automatically this has actually introduced this as a cantilever slab. Now there is another thing you need to also know all the time, that about these boundary conditions, because we have edge conditions, which I have explained. If you go down below the description of this, if you go to the YouTube channel, you are going to find where I actually took my time to explain a 2-edge discontinuous, 3 edges discontinuous, and all of that. I have explained all of that. So if you look at this panel, is a 2-way slab. This is a 2-way, this is a 2-way, this is a 1-way. So 2-way and 1-way are being placed in the same category as far as this software is concerned. Then another thing is the edge conditions, which I said earlier on, which you can as well place all those conditions in the software, in all your panels. Now if you go down here, you can see the deflection check is telling us that it's okay. So that means we are good to go, because I get a lot of questions about how will you know if any of the member is failing. This is one way to know. It will tell you whether the check is okay or it's not okay. Okay, this panel now, because this panel we have, this is 2 adjacent edges that are discontinuous. So all I need to do is just to click on 2 adjacent edges discontinuous. This is very tricky, I know. A lot of people tend to ask me about this. Then you can see this span is shorter than this span. So along the x-axis is shorter than the y-axis. So this panel, we have 2 edges that are discontinuous. So let's see where we position this. So you have to take out your time to place all of these things. So the modeling itself is where the major work is as far as this software is concerned. Once you can do the modeling perfectly, you are done with the entire process of the design, because analysis and design does not really take time. It will analyze and design it in probably 1-2 minutes. It is done. Okay, so we have here now, we have 2 short edge that are discontinuous. Okay, so similarly you can do for this one as well. This is 2 long edge discontinuous, because along the y-axis is longer than the than the x-axis. So this is 2 long edge discontinuous. Okay, then we have this one, we have 3 edges discontinuous. So we have 3 edges discontinuous, 1 long edge continuous. So this is the perfect one. So it discontinuous here, is discontinuous here, discontinuous here, then it's continuous here along the long span, so which is this. So this fits in perfectly with what we are doing. Then similarly for this as well, we have just 1 edge that is actually continuous. So just like this other one, that's what you do. So if you can really take out your time to just rearrange this perfectly. So this is 1 long, we have 3 edges discontinuous, 1 long edge continuous. So this helps when it comes to arrangement of your detailing. So if this is not really done properly, your detail reinforcement detailing may most likely not really come out well. Okay, so it may not detail it the way it's supposed to. Okay, so if that is correct, if all of these are actually fully correct, I am telling you a very big congratulations, because you can see this whole process did not even take me more than probably like 10 minutes to really achieve this model. Okay, so you can see how fast and easy you can actually go using this software. Okay, so if I come down to my modeling, all I need to do now is to copy this to the number of floors that I want to generate this. Okay, so let's say I want to just have one suspended floor. All I need to do is to leave it at number of floors, which is 2. So if I click on copy and create, now it will give me the first floor and then the roof level. Okay, these are what we call number of floors. Okay, it includes the roof level. So if I click on copy and I click on yes and I click on yes, now it has generated it for me. Good, perfect. You can see this particular support here is no longer here, so this beam is going to be acting on this particular beam as a secondary beam, which is going to be as a pointed load acting on this beam. Exactly. So whenever you have a design probably that is more complex than this, because this is very straightforward, but you can see it captures probably most of the challenges a lot of people may probably be having when it comes to modeling. Okay, so if you copy and create, then you click and apply and you click yes and then you close. So by the time you are done with this, you are basically done with the entire process of your model and your design. Okay, there is a problem here because I actually forgot to delete this particular support for this beam, because I am supposed to have deleted the support for this beam. I'm supposed to have deleted it. I'm not supposed to have a support there. You know, I deleted the one for just this beam, so this beam is acting on this beam, but I forgot to delete the support here at this edge for this particular beam, because I have a beam here coming out. So this beam is not going to be acting as a cantilever because there is a column here. This beam is also not going to act as a cantilever because there is a column here. So I only deleted for this beam, so this beam is going to be acting directly on this beam, but the beam will be acting on a column, and that is not what I want. So that is a mistake. Let's see if we can correct it from here. So the end support, I'm not supposed to have a column, so I'll click on no. So here also I'm not supposed to have a column here. That's a very big mistake that I made, and no, but the problem now is, let's go to floor modeling, column map. See if I can delete this support from here. Floor. Okay, but the problem is I have already copied it in the first floor, and okay, oh nice, so that has been corrected. Okay, nice, so that has been corrected. So let's check this now, if that is, because it has a lot of impact on the detailing, so one has to be very careful when you are doing your modeling. Okay, so this is basically what I want. So let's say everything is okay. The next thing I'm going to do now is to design this. So formally, you when this automatic design tab was not added, so you will have to load the structure, you know, analyze the structure, then you click on design. So in this case, you don't even have to do any of this. All you need to do is just to click on automatic design and click on yes. So once you click yes, you click on start automatic design and you click on yes. So this was the step I took you through from the beginning, if you can remember. So this time around, I'm not going to go through the process of explaining this. I'm just going to keep clicking yes. only. Okay, I'm just going to, okay, it seems like the former settings is still there. Okay, so the previous settings is this there, it's still there. Maximum bar spacing for this, I'll make it 300, no, 200. Apply changes, yes. Okay, so everything is still as it is. I may not have to input any information there. Click OK. So I have only one column type, so which is what I'm going to adopt, 225 by 225, and I'll click yes, and I'll click yes, click yes, yes. Here I'll make it 350 minimum, and here I'm going to make it 1200. I have explained all of this before, so there is no staircase here. I will close this. Detailing foundation layout, yes, detail it. So you can see my foundation layout detailing is already showing in the preview. So if you, once these windows close, you will see that. So this is 12 by 12 at 250 spacing, Y12 our base, which is good. 4Y16, which is good. 446Y10, okay, which is our links. So we have 4 number of reinforcement here. You can see the software is working perfectly. The software is very, very great. Honestly, I would advise you to really get the Quickcivilseries version 9. The software is very great. I have forgotten something very important again, but let me see if I can reanalyze this. I'm supposed to make the last floor level a roof beam, which I forgot. Okay, so you can prepare your calculation sheets. Can do all of that. You can see it's generating all of that. You can save it, but I don't want to go through that process. It will generate all of that for you. You can see the sheets in the background. To generate it for you, you can, someone was asking me whether the software generates sheets. Yes, it does. You can see you can even print directly from the software, but I always like to export to AutoCAD. You can export all design drawing sheets to PDF. Yes, you can export it to PDF, or you can export all the drawing to AutoCAD DXF, okay, which is the best fit for me. Okay, so you can export it anywhere and it will be exported. And you can see, just take your time to read through each of the information is popping up for you. Create a formatted AutoCAD DXF. Yeah, if you want to create it, you can create that, but I'm not creating any of them. So you can see all my detailing has been generated. My foundation, this is my foundation layout. If I come to the detailing tab here, if I click on floor, this is my slab and beam layout. Okay, so you can see this is my layout. This is telling us this panel, this is a cantilever, this is actually a one-way slab, this is two-way, this is two-way, this is two-way, which is very, very okay for me. It will not give me roof beam layout because I did not specify that as a roof beam. So so this is my foundation layout. This is my slab detailing. You can see the slab detailing. You can see how this software details our slab, which it comes out very, very clean. I'm telling you, look at, it's very, very good. You can see the detailing, very clean, very clean. The detailing is one of the selling points of this software. The software is very good when it comes to detailing. Like I told you, it is actually an indigenous software. It is also owned by a Nigerian, so a lot of Nigerian factor has been considered when it comes to developing this software. So if you are in Nigeria or you are in Africa, I would encourage you to actually adopt or get this software, because you know a lot of factors when you go to our kind of reinforcement and all of that we use now. Okay, I don't want to go into that, but a lot of Nigerian factor, like I said, has been considered in programming this software. Okay, so floor beam. If you come to your floor beam, you are going to see that particular beam that I made a cantilever. Okay, so which makes it very, very great. You can see where you have a beam, you can see we have a support at the internal support. You can see it's generated. In the previous version, I noticed it doesn't generate those internal, it won't show you, it will design it, but it won't show you those internal supports in the detailed drawing. It won't show but you can see here it's showing, and which makes it very great. So if you ask me, I must tell you that this version 9 is actually very great. You can see what we are having here. If you go down, you will find, see how this software generates your detailing. Okay, so okay, there is this cantilever beam, although I made a mistake from the beginning, so probably the software didn't interpret it well, but it will generate it for you, which I'm very, very sure it will generate your cantilever beam. You are going to see it come out cantilever, and it's very, very superb. Okay, so let's go back to the modeling. Let's come to view and see if I can correct that let's come to, the only thing is I will have to change this now to this level. I'll have to change it to a roof beam level, so I have to change it to roof panels, change current floor panels to roof panels. So if I click on yes, and I'll click on yes, click on apply. So the only thing I'll have to do is just run the design again afresh. So you can just take out your time and click on automatic design. It's going to design it all over again afresh now, considering the latest editing that has been done on it. And you can as well even make your ground floor level, which is here, a raft. If you want it to be a raft foundation, okay, you can turn this level to a raft. So if I come back to my model here and I click on raft panel, okay, automatically this whole floor will change to a raft, and I click on apply. You can see it has changed to panel 1 raft, panel 2 raft, panel 3 raft. Okay, so it's very easy, as you can see. If you love what you are seeing, just like this video, make sure you give it a thumbs up, subscribe to this channel. It's actually 100% free. Click on the bell icon for you to get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to really have a deeper insight of design. Okay, make sure you stay safe and make sure you stay blessed. Okay.